All right, let's take a look at lesson 512, your student work that was assigned from last time. Our first problem that I'd like to take a look at is 515, and we have a person named Kirsten that is shopping, and she sees a shirt on sale for $37.50, originally cost $50. I estimated the percent of the discount on the shirt at about 20%. And then I drew my diagram and I labeled all my parts. So I had my $37.50, which is the sale price. And I did some math to figure out that I was saving $12.50 here. That's how I got my other number for up on top. I did not know that this was 75% until I'd filled out my percent ruler. When I filled out my percent ruler, I got all the way up here to 70%, and then I realized that $37.50 is midway between 70 and 80. That's how I got my 75%. I also could have gone over here, and I actually did this too. 100% subtract 75% gives me 25% savings. What is the relationship between the discount, the sale price, and the original price? Well, we can take the original price, subtract the discount, and we get the sale price. Or we can also, as you see at the top of the next page, we can also take the sale price, add it to the discount, and we can get the original price. So that's a way for us to check our work. Then I went ahead and I did exercise 518, and I have some information up here. The most important part that I took out of this was 5 parts red paint and 15 parts yellow paint. I needed to find the total of the amount of paint in order to figure out the percent, because I need to know the percent is always part of a whole. And when I did the math here, 5 parts is red, the whole amount is 20, so that's reduced down to 1/4, which we can change to a different form, which would be 25 hundredths. Multiplying that times 100 gives me 25%. And the simplified ratio of yellow to red paint is 15 to 5 to start with. I can reduce it down to write it as a fraction 3 to 1, or I can write it with a colon in the middle as 3 to 1. The next part of the lesson that I'm going to go over quickly with you is a person named Janelle who earned 90% on a test at 63 points. And in order for me to do that, I started by making my percent ruler. My percent ruler, when I did that, I know that I have from 0% to 100%, so that was the easy part. And then I know that she got 90%, and 90% was 63 points. And I know that from my information up above. Again, a reminder that we always can go back into our problem and find some information that's going to help us to do what we need to do mathematically. If I have 63 points and I have 90%, the simplest way for me to think about getting to 100% and doing it accurately is thinking about what I do to 90% to get it down to 10%. Because typically when I have 10%, I can go and multiply up or scale it up. And I did my math up here. 90% divided by 9 gives me 10%. So then I do the same thing. My 63 points divided by 9 gives me 7. So these two numbers are important pieces of information for me to use to fill out my percent ruler. I fill out my percent ruler by skip counting by tens for the percentages, and then I skip count by sevens to get my points. And when I get up to 63, as I've been skip counting by sevens, I know that my math is correct when I get to 63 or when I get to 56 and I add 7 and I get 63. My total points on my assessment or on the test would be 70 because 7, 14, 21, 28, 20, 35, 42, 49, 56, 63, and 7 more gives me 7 points. So that's my 100% and my total points. Then when I went down here, initially, I started thinking about this problem, and the first um, thing that I try to do is I try to look for things that I have two of. In this situation, I have corresponding sides that are labeled with 50 and 30, or 50 meters and 30 meters. So I set that up, and initially I set it up small to big and big to small, and so I've got both of them here. When we do the math, and I know that this came up in our summative last time on chapter 4. Scale factor is always multiplication, and when I'm multiplying, I use the reciprocals. So if I'm going big to small, I'm going to use this one here. This is big to small. And we know that when we multiply by a fraction, we get a smaller number. This one, I'm going small to big. And that is why that is not crossed off. But I need both of them in order to solve this problem. When I am solving for x, I start with the number that I know, which is 15. I put it over 1 to make sure that I am able to think about this as a fraction. I multiply that times 3/5 because I'm going from biggest to smallest shape here. When I do the math, I've got 15 multiplied by 3 gives me 45. 1 multiplied by 5 gives me 5. Wow. And if I do the division here, I end up with 9. So x equals 9. For y, I am going from small to big, which helps me to remember that I need to have a fraction that is bigger than 1. Y equals 18 over 1 multiplied by 5 over 3. Do the math and I get 90 over 3, which reduces down to 30. And I should also remember that labels are important.